Hello there, cutie patootie math angel. Yes, you. Welcome or welcome back to Decaf-Math. ASMR. I hope that you're doing well. Today, let's work on factoring these 12 expressions, quadratic expressions, and we are going to be practicing using the FOIL method, but backwards. F-O-I-L. First, outer, inner, last. The FOIL method helps us to expand out the product of two binomials, two terms multiplied by two terms. And maybe 3 or 4 videos ago on this channel, I made a video on the FOIL method, and we've also mentioned it in passing in other videos as well. So if you want to take your time to break that down, feel free to do so. But for this, we're going to use it backwards because the FOIL method helps us expand out the product. And today we're going to take these and try and break it down back into the product of two binomials. So I'm going to tell you ahead of time that we can use this method for all of these quadratic expressions. I'm going to tell you that ahead of time because not all quadratics can be done in this way. And also, for these particular questions, this is not the only way to factor them. So, wanted to mention that we are going to be specifically using this one tool today, and the purpose is just to get some practice in, to have a little bit of fun with it, and I wanted to just invite you to join me. So of course math comes in layers. I've actually made a similar video in the past where the coefficients of the quadratic term, the variable squared term, in that video all the problems had coefficients of 1, so there was no number in front of the letter squared, the variable squared term. And when you don't see anything in front, that's an implied 1, because 1 times anything is itself, and 1 as squared looks kind of silly, but it's implied. So now we have numbers in front, and that just adds another little layer of complexity to keep track of, but the idea, the pattern is all the same. Okay, so this is a very natural next layer to that, and that's what we're going to play around with today. So we're going to take our time. If you want to practice this, you can definitely, of course, try them out, pause, compare answers, and let me know if you get anything different. But the nice thing about this is once you get, an answer for your factors, you can always multiply it back out just to double check. So feel free to play along. If you want a little challenge, you can try and do this all in your head, or you can just sit back, relax, and if you need the rest, you can just let the math wash all around you. Wash around you. And you can also just close your eyes and allow yourself to drift off to sleep. That's totally okay around here. Okay? So I hope that this blesses you however you need it. And thank you for choosing to spend some time with me. So let's just do this one by one. We have 12 questions here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So let's do this. Number 1, 2x squared this is the same set of problems from that video on the FOIL method, by the way. So I haven't actually worked these out, but I think at the time I was feeling kind of cheeky for this first question because even though the coefficient of this x squared term is not 1, this actually has a first factor of 2. So we don't have to actually factor this as though there's not a coefficient of 1, because if I pull out a 2, I can see that 2 goes into this, 2 goes into 4x, and 2 goes into negative 6. So I can get x squared plus 2x minus 3. 2x squared, 2 times 2 is 4x, 2 times 3 is 6 with a negative. So my point here, I think, was just that just because you're working on something new doesn't necessarily mean that all the stuff from before, like factoring via pulling out a greatest common factor or factoring where the coefficient is 1, that still can apply. And so, keep that in mind. These are just tools to add to your toolbox. That's one of the coolest parts about math, I think. So now we've greatly simplified this question to now need to just factor where the coefficient is 1, meaning that I can just keep this 2, and the two factors are going to be x and something and x and something, because 1 times 1 is the only way to get a product of 1 here while having positive whole number coefficients. So, and positive, because if we had like negative 1 times negative 1, it's kind of redundant. You'd end up factoring negative 1 from both, and you'd get 1 anyway. So, by default, we leave it as just x times x. So now we just want two numbers that multiply to be negative 3, and if the product is negative, that means one of them is going to be positive and the other is going to be negative. It's up to us to determine which one. And in order to get 3, we have 1 times 3 or 3 times 1, right? And that's it as far as whole numbers go. So it's either going to be plus 1 and minus 3, or minus 1 and plus 3. And the way we determine that is simply to check our outer, which would be negative 3x, the product, plus the inner, which would be plus 1x, or just plus x. So negative 3x plus 1x is negative 2x, which is not plus 2x. So it's the other way around. So that means it's going to be plus 3 and minus 1. So that our outer is 3x minus 1x is plus 2x. And we chose the first to multiply to be x squared in the first place, and the last to be negative 3. That's why we did the factoring. So we have our first and the last parts of FOIL down. So we just need to check that outer plus inner gives me this combined bit here. Okay, so this would be our fully factored form for this first question. Now, just something that might come up is that note that if you somehow wrote x plus 3 times x minus 1 like so instead with the 2 in front, you might notice that the outer would be negative 1x, inner would be plus 3x. That still gives me plus 2x, right? So if you switched the order here, it doesn't matter because these two are the same. They're equivalent because x plus 3 and x plus 3 is right here. X minus 1, x minus 1. And the order for multiplication does not matter. So it's kind of like saying if you were to factor 6 into prime factors, let's say, you can write that as 2 times 3 or 3 times 2. They both give you 6, and each factor can't be reduced any further. So it's up to you. For some reason, I think I prefer this one. Maybe because is the outer and the inner, like the outer is positive and then minus, I don't know, but they're the same. Okay, so in this case, because we're just dealing with x and x, as long as you get the correct constant part and the outer and inner part to combine, we're good to go. Another thing that might come up is that, let's say you didn't notice that you could pull out a 2 to simplify things. It doesn't matter. You can go ahead and factor this as though there is a coefficient of 2. But when you get an answer for your 2 binomials, at least one of them is going to be able to be factored further. So you're going to end up with the 2 as well. So that's kind of like saying, let me think of a similar example. So if I said factor 12 down to its prime factors, let's say you noticed that you can pull out a single prime factor first. So let's say you could do 2 and 6. So you pull out the 2 first, and then you factor 6 into 2 and 3. It's something like that. So you can pull out this first 2 and then break it down and then break this down further. Or you can just do like, maybe this wasn't a good example. Maybe you break down, let's say like 24 maybe. I don't know. Maybe 24. So maybe something kind of logically equivalent would be noticing that you can pull out a 2 and then do 2 and 12 and keep breaking that down, versus breaking this down into 4 and 6 and then knowing that each of these can be broken down further. I don't know if that's a good example, but that's the general idea. Is if you pull out a simple first factor, it does make the rest of the factoring easier. But if you don't notice that, then just go ahead and do this, and each of your factors, or at least one of your factors, can be broken down further, and you'll get the same answer. So let's do that in this case. We would, in theory, we still want something plus or minus something times something plus or minus something, again with our linear terms. And because this is 2x squared, that means that one element has to be 2x and the other has to be x. And we might as well just pick this pairing. It doesn't matter again, because the order doesn't matter. We can do x and 2x, but I'm just going to do it this way. 2 times 1 is the only way to get a product of 2 using positive whole numbers, right? Positive integers. So we know that it's going to be 2 and 1. I like to write it like this as an anchor before dealing with the factors of this part. And by anchor, I just mean that if you don't have 2 and 1 here, if you have an x and a 2x, then your outer and your inner part here, outer plus inner, doing this part, might give you something equivalent, and you'll kind of go in circles. So you might as well just anchor this part and do everything relative to this. And so in this case, what you put here and here does matter. So whether we do -1 plus 3 or plus 3 and -1, it matters. And it's important to get the correct constant aligned with the coefficient of the linear term here. So for instance, 2x minus 6 times x plus 1 is not the same as 2x plus 1 times x minus 6, because these are not the same factors, unlike this one. So we have to be careful there. And I don't know if that's the correct answer or not, but that would be very lucky. So we have 2x and x. Of course, if you learned this differently in school or you have a preferred method, by all means follow that. This is just how I like to do it, so I don't have to memorize too much. So now we factor 6, or rather -6. So the product is negative, so that means one of these is going to be plus, the other is going to be minus. And we want to determine if it's going to be plus and minus, or minus and plus. So in that case, all of the possibilities would be factors of 6 or pairs of 6. So let me write out all of the possible options so we can see it. but I promise that in the future it'll become more second nature. You won't have to write every single thing down. But just for the sake of the exercise, let's do this at least once. So one of these is going to be positive, the other is going to be negative, and factors of 6 would be 1 and 6, or 2 and 3 as pairs, right? So we could have -1, +6, -6, +1, +1, -6, and +6, -1. And then we have the same thing for 3 and 2. So +2, -3, -2, +3, +3, -2, -3, +2. Okay, and I'm sorry if this pains you to see, if you don't like to write things out. But this is all the possibilities for these two slots. Now again, there will be a bit of symmetry, and the actual elimination process goes pretty quickly once you know why you're doing what you're doing. So it's not that bad, but what we're now looking for is for the outer and the inner parts to combine to give me +4. So let me show you what I mean by the symmetry. If I have +6 out here, then when I do the outer, I'm going to have 12, right? 2 times 6 is 12. And then my inner part will be -1 with an x. So 12x minus x is 11. That's too big for my 4x. So it's definitely not this one. Okay. Then whatever I put here, I'm basically multiplying by 2. So 2x times 1 is positive 2x. And then inner will be -6x. So that's 2x minus 6x is -4x. So it's not plus, so not this one. Okay? So if I have a -6, that's the -12 problem. It's too big for an absolute value of -12 will be positive 12. It's just too big, right, to have a difference of 4. So not this either. But for this one, this would work, because if I do -1 and +6 here, I have -2x plus 6x is +4x, right? -2 plus 6 is a +4. So I know sometimes we think of it as differences or sums. It really just comes down to working with negative numbers or positive numbers. But what might help is to think about your outer and your inner as a whole, and then you can deal with the fact that you have this 2 times this negative number plus something. So in order for these two to have one positive and one negative, you want to consider if this is going to be plus or minus, and if this is like a larger number or a smaller number. Because if it were, let's say, 11x, then compared to 2 and 1, you kind of need to multiply by something a little bit bigger. So 2 times 6. I don't know if that makes sense, but as you do more and more questions, these are kind of things that kind of pop up in my mind, is just looking at the difference of things or the sum of things, but then you just have to also scale it to and use this coefficient, whatever it may be. So sometimes it's 2x and x, sometimes it's 2x and 3x, or something like that. So in this case, this pairing works, and as long as you find one that does work, you can just take it from there. So this would work, and then you want to check that each factor is as broken down as possible. So this one can actually be factored further into a 2 times x plus 3, because 2 goes into 2x and 2 goes into 6 3 times. So now we get this 2 times x plus 3 times x minus 1. So that would be the same as this answer. If you look at this particular list, though, you might also notice that we can have a different answer that also works, which would be, I think, this one, because we would have 2x minus 2 times x plus 3, and this gives us an equivalent answer, because in this case we could factor out a 2, and we would have x minus 1 times x plus 3, like so, which is the same as this answer. So in this particular case, because we have a greater common factor other than 1 here, we're going to have a few possibilities, but they're going to all lead us to the same fully factored answer. That's like saying if we have 3 times 8 or 2 times 12, if we keep breaking it down, we'll get the same final factor. Okay, but I think this was a while back, but I think the answers for the rest of them should be all pretty clear, but this was just to make a point. Okay, so let's continue on. Doing great. Number 2. 6y squared plus 13y minus 5. Okay, so y is our variable here, and we have y squared, 6y squared plus 13y minus 5, so we want something y plus or minus something times something y plus or minus something. So in this case, we can start with our anchors, as I like to say. So we could have 6 and 1, or 3y and 2y. So it could be 6y and y, or 3y and 2y. And so I say these as anchors again, because then we don't have to worry about 6y and y, and then y and 6y. We just set this and then adjust the constant part to match this part. So 3y and y. So I tend to pick the bigger one here and then the smaller one here. But that's up to you. But this way we don't have to do 3y and 2y and 2y and 3y to check it, because we would just end up getting the same corresponding constants to this part. So these are my anchors, and so now it's a matter of adjusting our constant part to multiply to be negative 5, and then the outer plus the inner part needs to be positive 13. So with the product of negative 5, again that means one has to be positive, the other has to be negative. We have to decide which one's which, and we like prime numbers because the only factors for 5 would be 1 and 5. So it's either going to be plus 5 and minus 1, or minus 5 and plus 1, or plus 1 minus 5 and whatever the other one I didn't say. And so we can check again one at a time, but really we're just looking for the pairs that give us the plus 13. So in this case, if let's say we had plus 5 and minus 1, when we do the outer and the inner here, this would be 5 times 6, or 6 times 5, which is 30y, and then minus 1y is 29y. So relative to this, it's a little too big. So we would also try, so that's why you wouldn't do negative 5 either, because that would be negative 30y. So you don't really have to bother with that. So you could try maybe, plus 1 and minus 5 or something like that, or minus 1 plus 5, but then that gives us a difference. So if it helps, you can consider the absolute value of the difference here, but this would give us 6y minus 5y is 1y, so that's too small. So we're just not going to use this pairing. I believe that's just all the possibilities. So for this one, we could have plus 5 and minus 1. That looks like the one we're after. So we have 15y minus 2y is positive 13y. So usually you'll get the absolute value of the answer in some way, and then you can adjust which one's positive or negative depending on if this is plus or minus. Okay, so this is going to be my answer here. So some people like to write out all of the factors, like just plus or minus 6, plus or minus 1, or even, minus plus 1, like that. Whatever you want to do is fine with me. Plus or minus 3, plus 2, whatever, and then the same thing for this, plus or minus 1, plus or minus 5. And so some people adjust the plus or minus part later instead of listing this all out. But I like the anchoring trick, and I don't really like to memorize much stuff. So, okay, so number 3, 4x squared plus 11x plus 7. Okay, so in this case, right away you could do 4x and x, or 2x and 2x. So just factoring this first part, 1 and 4, 2 and 2, and I'm just going to put 4x and x as my anchor, 2x and 2x here. So I have 7 here, nice and prime, that's great. It's all positive too, and so from this plus 7, I'll know that it has to be plus 1 and plus 7, or plus 7 and plus 1, and technically it could be minus 1 and minus 7 because two negatives multiply to be a positive as well. But then at that point I see a plus 11x in the middle, so that means it's all going to be positive. And so it's going to be plus 1 plus 7, like so, or plus 7 and plus 1, or the same for here. Okay, so if this were a minus right here, I would have negatives for both, even if this is a plus 7. But in this case, everything is positive, and I might notice that 4 plus 7 is 11, which is nice. That means that I would have 4x plus 7 and x plus 1, which is really nice. So, plus 1 plus 7. And this is a pattern that you might see. Plus 4x plus 7 is 11x right away. So that's great because you're going to factor the 7 into 7 and 1. So the 1 in the 4 part keeps the 4. Then you add 7. So if you did the 2x part, if you put 7 out here, you'll get 14x, which is too big. If you put 1 here, you would have 2x plus 14x, which is still too big because they're both 2x. So our answer is 4x plus 7 times x plus 1. And again, if you want to check, you can always expand it back out using the FOIL method. Excellent. Okay, number 4. 5x squared minus 2x minus 3. Okay, so similar deal here. Some are more complicated than others. We do the same method, so we want 5x and x. Again, 5 is prime. The only way to factor that with whole number factors, positive ones, would be 5 and 1. And I'm just going to anchor at 5x and x. And because the product is negative here, one's going to be positive, the other is going to be negative. And because 3 is also prime, the factors are going to be 1 and 3. But we need to know if it's plus 1, negative 3, minus 1, positive 3, minus 3, plus 1, positive 3, negative 1. But I see here that I have a negative 2, which means that my outer is either going to be more negative than my inner part. So like minus 5 plus 3 intent to get negative 2. Or I'm going to have a smaller outer part here and subtract a larger number. So in this case, it's going to be a minus 1 plus 3 because I'd have negative 5x plus 3x gives me negative 2x. So you might think of it as having a difference of 2 here and then adjusting the positive and the negative. So let's say you're in a hurry, you're taking a test or something like that, and you're panicking. You can just go ahead and start with factors just that you know. So let's say you're like, oh, okay, I'm going to put a plus 3 here and minus 1. When you check this out, you have a 15x minus x. That is 14x. That's too big and it's positive. So you can consider which way it needs to be adjusted. It needs to be more negative, and the absolute value needs to be smaller, and whatever's on the outside here gets multiplied by 5, so that means this outer number should probably be smaller. That's why I would put the 1 here, not the 3 here. Okay? So our answer here would be 5x plus 3 times x minus 1. Excellent. Okay. So, number 5. We have 4t squared minus 49. Okay, this is a little trick one because this has a slightly different form, right? We're missing a linear term. This is actually a special case. But let us use the same method that we've been doing here for this special case, and then we'll see what happens. So what we can do is plop in a 0t here. 0 times anything is 0, so we might as well put in a linear term, as in not have 1. But we can follow the same method here, factor the 4t squared part. So that's either going to be 4t and t, or 2t and 2t. Those are our anchors. And now we want these two numbers to multiply to be negative 49. So one's going to be positive, one's going to be negative. And we want the outer plus the inner to give me 0, which kind of implies we want it to be nice and pretty, right? Whatever we add, we also want to subtract that same number to give me 0, because, you know, if we have negative 26, we need to add 26 to give me the 0. So everything's going to be nice and balanced. And what do you know? 49 is 7 squared, or 7 times 7. So if I happen to add 7 and then subtract 7, my outer here is going to be 14t. My inner is negative 14t. Wow, that's 0. So it's going to be this pairing right here. And just to double check that, you know, we could have negative 1 and 49, or plus 1 and negative 49, or negative 7 and 7. But anything that you do here, like this, is not going to give you 0. You're going to have 14 minus 49t. Way too negative. No. So we want this, right? Or in this case, we could also do 2t plus 7 times 2t minus 7, just because these first terms are the same. So this is a special formula for the difference of squares. So we might also notice that this is 2t squared minus 7 squared, and a minus b, this being a, this being b, a squared minus b squared is a minus b times a plus b. So this is actually a special formula, but that really does come from the FOIL method. It's just that the outer plus the inner parts give you 0. They cancel. So whenever you see differences of squares, you can use this formula. But we can just still plop in a 0t, and it still works. Very satisfying. Okay, so number 6, 7s squared minus 25s plus 12. So now we can do the same thing. We have 7s squared, that's nice and prime. So we can do 7 and 1, the only factors. And so these are my anchors. And now we have more factors for 12, right? 1 and 12, 2 and 6, 3 and 4, 4 and 3, 6 and 2, and 12 and 1. In this case, it's positive, so these two constants are either going to both be positive or both be negative. But because we have an outer and inner, it needs to be a negative 25. That means these are both going to be negative. Okay, so that's a good thing. That's a good starting point. Now we just want to know which pairing of what I just said is the right one. 3 and 4, 4 and 3. Right, so we want the right ones to line up with the 7 and the right one to line up with this. So you can write out every single pair, or just kind of keep that in mind as you work through them. So dot 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 dot. So if you have 12 out here, that's going to be way too negative, because whatever you put on this side, the outer is going to be multiplied by 7. So 12 times 7 is 84. 84s. With the negative is negative 84s, and then you're subtracting even more. So no way, too big. Times 6 is still too big. That's going to be 42, which is still too big. With the 3 and 4, it looks pretty tempting because we have a negative 28, and then you have this 3, and you're like, wait, 28 minus 3 is 25, but we have 2 negatives, so you ending that. But this is what we need, I think. So we have negative 21s minus 4s is negative 25s. So if you like to think of negative numbers like negative 1 minus 4 is negative 5, if you like to think of that as negative of 1 plus 5, then you might consider sums and then tacking on a negative. And that's where I think some teachers like to think of sums and differences between the numbers. That's up to you how you want to adjust that. But keeping in mind that you have a plus here, so they're both negative, means that you're basically doing negative of this outer number plus the inner number. So just adjust the absolute value accordingly, so you can pretty much eliminate this, and you're not really necessarily testing every single case here. You can just do like half of them automatically, and then kind of adjust based on how large of a number this is. So our final answer is 7s minus 4 times s minus 3. And if there is no larger greatest common factor here other than 1, these are as reduced as possible. You can't break it down anymore anyway, so. Very good. Let's do number 7. So at this point, I think I'm just going to work through them more. I think you can get the pattern here. The only difference between like the more complicated ones and the more straightforward ones probably just has to do with the number of factors and possible pairs. So like we said, we like prime numbers, but sometimes we have to factor this first part and the second part. That can be a pain, but it's the same exact process. So I'm going to work this out here. So with 9, we can have 9p and p, or 3p and 3p, I'm seeing. And then we have a plus 8 here, but negative in the middle. So these are both going to be negative, rather than both being positive, because if they're positive, there's no way it's going to be negative here. So factors of 8 are 1 and 8. You could have 8 and 1 in the other order, 2 and 4, 4 and 2. That's it. So if I have 8 out here, that's going to be negative 72. Too big. So just automatically, no. Same thing for 4. That would be 36 or negative 36p. Minus 2 is not going to be negative 18, so definitely not that one. It's not going to be 2, because if I have 2 here and 4 here, this is negative 18p already, and so subtracting anything off of that is not going to be negative 18p. So definitely not that. And 1 and 8 could be pretty close, but if we check this, we have negative 9p minus 8p, and that is negative 17p, not negative 18. So close, but not quite. So definitely not our 9p and 1 pairing, but we try all these pairs for this 3p minus and 3p minus, and I'm going to go ahead and put this, because I'm seeing here negative 12p minus 6p is negative 18p. So this is actually quite fun, I think. Let me know if you enjoy this. But I know that there have been some people in the comments that are like, I love factoring, so this is for you. And so Same thing, if we put an 8 here, that'll be negative 24, already 2 negative. With 8 times 3 here, still 2 negative. So just going through them, it goes pretty quickly, even if there are a lot of combinations. So our final answer for this one is 3p minus 2 times 3p minus 4. And again, since we have 3p and 3p, you might have the flipped situation, right? You might have the 3p minus 4 times 3p minus 2, and that's okay. Alrighty, so number 8. 7d squared minus 32d minus 60. Alright, 60 has quite a lot of factors. Luckily 7 does not, it's just 7 and 1. But because we have a negative 60 here, one's going to be positive, the other is going to be negative, and we want the outer and the inner to be negative 32. So we can do 1 and 60. So one's going to be plus and one's going to be minus. So 1, 60, 2, 30, 3, 24, 15, 5, 12, 6, 10, and then pretty much the flip of everything, 10, 6, 12, 5, 15, 4, right? So just the other way around. And so we want to keep track of which one to put here. So whatever I put here, though, this is nice. This is a relatively small number. It's not like, 420 something. And I say that because if I put 60 here or a minus 60 here, it's going to be negative 420. So then add 1 is going to be negative 419t, which is way too big. So we can just start crossing these out. 30 times 7 is going to be 210 or negative 210. So it's still too big. 140 is still too big. 105 is still too big. 84 is still too big. 10 and 6, so the pairs can still work, but our smaller number is going to be here and our larger number is going to be here. And another little thing is perhaps we see a 2 here, so I'm just going to, let's see, negative 42 plus 10t. That 2 is actually just because I saw the 42, so I did that. That's actually not a hint, really. But negative 6 times 7t is negative 42t, and then plus 10t. So if you happen to get like a negative of the answer, or like if you get plus 32, you just have to flip the signs, that's all. But this is going to be our answer. So I don't know what other hints to give other than to just keep track of which one you're multiplying by the larger number and looking at how large the absolute value of this middle number is, and also noting if this is positive or negative. So if you're really finding the difference between the products or the sum. But that's our answer. 7t plus 10. 7t plus 10 times t minus 6. Okay, number 10. 9x squared plus, no, number 9, right? We skipped this one. Okay, number 9, 10n squared plus 89n minus 9. Okay, so this is an example of looking at how large this middle number is relative to its factors. That might be kind of a clue. So factoring out this 10n squared, it could be 10n and n as your anchors. And you could have 5n and 2n. 5 times 2 is also 10. So for 9, I have 9 and 1, or 3 and 3. 3 and 3 and 9 and 1. But because it's negative, one's going to be plus 1, plus, and the other one's going to be minus. So I might see here that I have like an 89, kind of like for the 4 and 7 one, adding to 11. I might notice here that 90 minus 1 is 89, So that's kind of just straight up how we would get something so large, right? 9 times 10 would give me the 90 and then minus 1 off. So we could do that, or if we tried, plus 9 minus 1, we're going to only ever get to 45 and then subtract something off, which is not going to be big enough. So that's what I mean by like relatively larger. So you have to do 9 times 10, and if you broke this down to 3 and negative 3 or something, you'd only ever get as large as 15n minus 6n, so that's going to be too small. So our answer over here will be 10n minus 1 times n plus 9. Okay, so just kind of keeping track of how much we need to contribute with each factor here. Number 10, we have 9x squared plus 6x plus 1. Okay, this one's also kind of cute. So we can do 9x and x, or 3x and 3x. But the only factors for plus 1 is 1 and 1, 1 and 1, and or negative 1 and negative 1, but this middle part is plus. So we know it's either going to be plus 1 of this one, or plus 1 and plus 1 here. So it's kind of a little logic loop here, which is cute. And we note that this one is going to be 9x plus 1x is 10x, so not quite too big, but 3x plus 3x is 6x. So this is our factorization, 3x plus 1 times 3x plus 1, or just 3x plus 1 squared, because we have to have the same factor. So again, this is actually one of our special formulas as well for multiplying this stuff out or factoring, like our difference of squares situation. This has a special form of, I can rewrite this as 3x in parentheses squared plus 2 times 3x plus 1. And unless you kind of know that off the top of your head or recognize that pattern, that might not, be obvious right away. But this is our a plus b squared is a squared plus 2ab plus b squared formula. It's just a shortcut. If you do a plus b times a plus b and expand that using the FOIL method, the outer and the inner part will combine to be 2ab. So in this case, we have our 3x squared would be a, and then we have this 3x, which is the 2 times the ab part, and the b being 1. So it actually works out this way. This is a plus b squared. Gives me this. I thought it was cute, but that's why I said that you can use this backwards FOIL method for all of these questions, but you don't have to. Okay, and that's really where the special formulas come from anyway. So we have number 11, negative 7x squared plus 2x plus 5. Okay, so now just to show us that we don't have to have a positive coefficient, that's fine. I personally like to factor out this negative so that I can have a positive coefficient here, just to factor out that negative. You end up having to do it anyway, because otherwise you're going to end up with a factor of like negative 7x and positive x like this, or 7x and negative x like this, but then you would end up factoring a negative 1 anyway, so you might as well do it at the beginning. So now we can do this as we normally would, and so we can do 7x and x again, and because this is a negative 5, we have 1 and 5, or 1 and negative 5, or negative 1 and positive 5, and again this could be the negative 5 here, and 1, all that. So 1 and 5 are the absolute values of the factors, and because this is negative, we want the outer and the inner to be negative too. So 7x plus 5x is negative 2x, and we put a negative right here on the side. So again, if we put plus 5 or minus 5 here, the outer would be 35x or negative 35x, which is too big for this negative 2, even if we added 1 or subtracted 1. So we want the 7 contribution to be something smaller so that they're closer together. And then from there, it's just putting which one is positive and which one's negative. And in this case, we want more negative and then less positive so that we still get a negative answer. And then we still have our negative. So our final answer is negative, parentheses, 7x plus 5 times, parentheses, x minus 1. And so if you did this as a negative 7, you might have negative 7x minus 5 times x minus 1, or 7x plus 5 times negative x plus 1, but you should still factor out a negative, because you can at that point. So, same answer. Very good. So if you are practicing this or you're learning it, I'm hoping that this helps you get the hang of it a little bit at least. But otherwise, I hope that you're enjoying yourself, or maybe asleep by now. That's okay. Hope you're having sweet mathy dreams. So we have 3y squared plus 5y plus 2. Everything is so nice. I had to round this out with the beautiful one. So 3 is prime, 3y and y has to be 3 and 1. These are our anchors. 2 is prime, so it has to be 1 and 2. But is it going to be plus 1 plus 2? Or is it plus 2? Wait, plus 2 plus 1. And because this middle part is plus, it's got to be plus and plus. Otherwise, if this were negative, you could do minus. You'd have to do minus minus, right? So because the product is positive, they both have to have the same sign. And because the middle is plus, we put this in. So if I did plus 2 plus 1, that would be a 6y plus 1 is 7y, so not quite. But if I do a simple switchy switch, it'll just be plus 1 plus 2. So we have 3y plus 2y is 5y. This one is like the most satisfying, I think. 3y plus 2 times y plus 1. Nice and simple. 3y squared plus 3y plus 2y is 5y. Plus 2 is 2. So it's a nice one to wrap up on, and I hope that you enjoyed going through these with me. And if you just want to give yourself some extra practice, you can just take two linear binomials, multiply them out, and combine the outer and inner part to give you this middle term, then walk away. Do a bunch of those, walk away, come back, and see if you can factor the other way. Okay, if you're asleep right now, I'm wishing you sweet, sweet mathy dreams. And if you're not, I wish you a wonderful rest of your day or night. Thank you for hanging out with me. If you have any further questions here, let me know. And sending you much, much love. I'll see you around for more math very, very soon, okay?